For this question, they tell you that P and Q are the sum of roots and the product of roots. So some notes. You learn in Form 4, Chapter 2. For any quadratic equation, ax squared plus bx plus c equal to 0. If it is already in this format, then sum of its roots should also be always negative b over a, and the product of roots is equal to c over a. We are going to use this, and this 2 marks is really easy relatively in section B. You should all able to solve this one. Based on the quadratic equation here, x plus 2 times x minus 2 is equal to x minus 1. It's obviously not this format, so our first mission is make it exactly the same as this format first. To do this, we need to expand the bracket, remove all the things from one side. So this is x squared minus 4, and this is 8x minus 8. Move everything to one side, x squared minus 8x, and then plus 4 equal to 0. So we transform this equation to this format, which is the same and ready for the transformation. The sum of roots, P is equal to sum of roots. That means negative something over something. B is negative 8, A is 1. So be careful when you are substituting some negative value. You need a bracket, and make sure you don't make any careless mistake. Q is equal to product of roots. So it's equal to C over A. C here is 4 while A here is 1 is equal to 4. We know P is 8 while Q is 4. And then after that, part B is basically another topic which is about logarithm. And one very important thing is whether you can read the question carefully. Some of you just use your imagination, like Man use the is that Man or some other? Use the imagination to think it is something in his mind, but do not read carefully. First term and second term of a geometric, so we are talking about A and R, the ratio. And then this one, they just simply tell you that it is log Q. Q here, that means 4. And then the second term here is log P. P, that means 8. And then this is a GS, which means that time the ratio, you get the second term, time the ratio, you get the third term, so on and so on. We need to find the greatest value of alpha such that always give you the relation that you can continue. The sum of alpha plus 1 term and this term less than this amount. So we are not talking about the sum of the first n term. We are just talking about the n term. So here is T alpha plus 1, but not S. Only one term here, and then another term, 2 terms only. But many of you think that it is the sum from the first one until the alpha plus 1. No, it's not. It's just talking about this term plus this term, less than this amount. This is what asking. If you realize that and you're able to handle some logarithm calculation, it's not that difficult. In part B, given A is equal to the first term log 4 directly. And I prefer to tidy up 4 is 2 power of 2, that means 2 log 2. I have incentive to do so is because this is 8, also 2 power of something. And R, which is the ratio, we always use the next term and then divide by the previous term. We get what is the multiplier here. So that means log 8 divided by log 4. That means 3 log 2 divided by 2 log 2. So it's 1.5. The common ratio is 1.5. So after that, we can easily write this one down, and our condition t alpha plus 1 and then plus t bracket 2 alpha plus 1 less than this. Don't forget it. In GS, Tn is equal to Arn minus 1. A and then times R power of n minus 1. We repeat the same operation for n minus 1 time. So here we use the same logic. This is AR alpha plus 1 minus 1 plus AR. This is 2 alpha plus 1 and then minus 1. Tidy up first, that means AR power of alpha plus AR power of 2 alpha. And now we can replace A and R by ourselves. A is 2 log 2. And then R is 1.5 alpha. This is 2 log 2. And then 1.52 alpha. You may realize that this is basically a quadratic inequality because this is unknown and then this is power of 2 of it. The index power is 2 to 1 to 0. So we are going to solve a quadratic inequality. But before that, I don't like to log 2, so I divide both sides by 2 log 2 first. So 2020 log 2, I can take the index out and then divide by 2 log 2. So it's greatly simplify our calculation. We don't need to handle the log. 1010 1.5 alpha plus 1.52 alpha. To solve quadratic equation the same, I need to rearrange it like this form. Put everything to one side and descending power. So 1.5 power of 2 alpha and then plus 1.5 power of alpha and then minus 1010 smaller than 0. The same as solving quadratic, I need to use cross method or quadratic function to factorize it. And in your brain, this is 1 time times 1 time. So A is equal to 1, B is equal to 1 also, while C is equal to negative 1010. We use calculator formula 1. Formula 0, 1, 1, 1, negative 1010. We got this amount and this amount.